Hopefully this is the last goddamn take. I want to go to bed. Okay, glycolysis, obviously, first step in the fucking cell respiration. I'm talking first. There's a reason for that. Glycolysis is the most common step in organisms. Every organism does it. That's why scientists think that everything stems from one organism, because every organism performs glycolysis. Kind of obvious, I guess, if you know that happens. Glycolysis, what does it mean? Glucose, lysis, to break down or to slice. Easy. So you're just breaking down glucose. Why? To gain more energy. Ooh. So your first step, where you see that says ATP to 2 ADP and 2 phosphorus, that's called your energy investment phase. Just because you're investing energy into glycolysis to be able to create more out of it. So you're just saying that, breaking it down, boom. Right? After you invest, what do you get? You pay off from it. Hence, energy payoff phase. It's just telling you that you gain material afterwards. So you do energy investment twice. So now you have 4 ADP and 4 phosphorus. You create 4 ATP. Boom, more already. Then you have 2 NAD plus, and then you have 4 electrons, 4 hydrogen ions. That combines to 2 NADH, and then 2 hydrogen ions. The electrons help the hydrogen ions combine with the NAD plus to have those electrons still, and then the other 2 electrons just go into the hydrogen ions. That's it. Boom. Then after you're done with all that, you have what glucose finally breaks down into, because glucose itself goes down and basically just becomes a 2-pyruvate and then the 2H2O. That's basically it. That's basically what you need to know. You just need to know glucose turns to that. Then you have minus 2 ATP here, but plus 4. Do the math, you fucking idiot. So now you have 2 ATP net. You gain 2 ATP because you invested in it. Easy. And this just tells you what you're doing, why this goes into here. Think, right? So, where does this lead to? So, it's necessary because if you don't do this, you don't have pyruvate to complete the other steps in cell respiration. Because pyruvate allows you to perform aerobic and anaerobic respiration. Anaerobic, also known as fermentation. So, aerobic just uses oxygen. This one just doesn't use oxygen. But without the pyruvate, you're unable to complete the cell respiration. So you need to go through glycolysis to get it. That's pretty much it.
What's up, guys? It's Quandale Dingle here. After glycolysis, the process continues if oxygen is present. This is part of aerobic respiration. Here, each molecule of pyruvate travels into the mitochondria. Inside the mitochondrial matrix, pyruvate is broken down.
Ever since I was a kid, knew I was a shit. Try to keep on it,
One carbon atom is released as carbon dioxide, a waste product that we breathe out. The remaining 2 carbon fragment combines with a molecule called coenzyme A to form acetyl-CoA, which will move into the citric acid cycle next. During this reaction, NADH is reduced to NADH, which means it picks up high-energy electrons that will later help make ATP in the electron transport chain. So overall, each pyruvate produces 1 acetyl-CoA, 1 NADH, and 1 molecule of carbon dioxide. This step connects glycolysis to the Krebs cycle.
There is a village known as Cell City, who is in desperate need of energy sources. They are starving and dying. The journey starts with glucose, a 6-carbon structure which underwent glycolysis and eventually got turned into 2 pyruvates that are each 3 carbon molecules. So in their desperate situation, the townspeople sent one of the pyruvates to go get on a quest to get energy for them. However, in doing so, he realized that he had 3 legs and that would make him very slow, so he had to ditch one out. This represents the pyruvates turning into acetyl-CoA. The chosen one is sad that he has to leave his partner to go on the journey, but now he is better for it and he has a cooler name called acetyl-CoA. As acetyl-CoA was walking, he met somebody named oxaloacetate and they quickly became best friends. They instantly hit it off, and with acetyl-CoA's 2 molecules and oxaloacetate's 4 molecules, they become a 6-molecule structure and become an unstoppable force called citrate. This new duo, citrate, was walking when all of a sudden 2 oxygen bandits came and stole one of their legs. Us 2 oxygen atoms are gonna take your carbon leg and escape the matrix with it. This is how CO2 gets released as a byproduct, and also how NAD plus turns into NADH plus. Citrate is now a 5-carbon molecule and is undergoing a new name called alpha-ketoglutarate. He continued his journey, and once again, another 2 oxygen bandits came and demanded the same thing. The dynamic duo is falling apart. They only have 2 legs and 2 arms, and are now called succinate, which is a 4-carbon-based molecule. This process is so painful for them that they cried with a wail of so much energy and force that the town could feel their power. This represents when ADP gets turned into ATP. Still, succinate is forced to still move on, and eventually they see a traveler named FAD. They see him shapeshift into a new form where he had 2 swords and he took on the name FADH2. Still, they continue wandering, and this is representative of NAD plus getting converted into NADH plus and FADH getting converted into FADH2. Once the duo had reached the last stop in their journey, they saw a familiar looking face. It was the other acetyl-CoA who wasn't chosen, or so he thought, but actually he did the same exact quest. So they reunited and decided to sit together because they were super tired and died. Now, it was just the oxaloacetrates, and he realized that he himself was basically back to exactly where he started. He began to realize what his true mission was, and he looked at what he had accomplished. He ended up with 4 CO2s, 6 NADHs, 2 FADH2s, and 2 ATPs, essentially giving energy to Cell Village. The whole purpose of the trip was to get energy, and that's exactly what he did. The process started off with acetyl-CoA, which was joined by oxaloacetate, and ended up with just oxaloacetate once again, and the process was made to be repeated over and over and over again. The best part about this quest or cycle is the fact that you don't have to complete the entire thing just to get your desired products, but rather, each product is gained throughout each and every little step.
Sometimes cells don't have oxygen. They can't perform aerobic respiration, so they switch to anaerobic processes called fermentation.
Oh my God! Wow!
Fermentation happens in the cytoplasm and allows cells to keep producing a small amount of ATP even without oxygen. It starts again with pyruvate, the end product of glucose breakdown. During fermentation, NADH gives up its electrons and turns back into NAD+. This step is critical because it regenerates NAD+, allowing glycolysis to continue producing 2 ATP per glucose molecule. This process begins with glycolysis, where glucose is broken down into pyruvate, producing a small amount of ATP. In the absence of oxygen, pyruvate is converted directly into lactic acid by the enzyme lactate dehydrogenase. This process regenerates NAD+, which is needed to keep glycolysis running, allowing the cell to continue producing ATP without oxygen. It occurs in some bacteria and in animal cells. Glucose is broken down into 2 molecules of pyruvate through glycolysis. This step produces a small amount of ATP and NADH. Each pyruvate molecule loses a carbon dioxide and becomes acetaldehyde. Acetaldehyde is then converted into ethanol by using electrons from NADH. This step regenerates NAD+, which is necessary for glycolysis to continue. Alcohol fermentation converts glucose into ethanol and carbon dioxide, allowing cells to produce energy without oxygen.
In this first step, NADH is oxidized into NAD plus ions. H plus ions, represented by the golf balls, go through the protein complex into the intermembrane space. In this process, electrons, the colored beads, are left in the protein complex. The electrons are then taken into the electron carrier. FADH2 donates electrons into the second protein complex, losing 2 H+ ions, becoming FAD. These electrons join the electron carrier and are dumped into the third protein complex. The H+ ions go through the third protein into the intermembrane space. The electrons are collected in the electron carrier, taken through the fourth protein, where they join 4 H+ ions and 2 O2 molecules to form water. The 2 yellow golf balls represent the O2 molecules. Lastly, the H+ ions from the intermembrane space are sent through ATP synthase, where they will provide energy to bond a phosphate and ADP, forming ATP. Phosphate is represented by the coin, ADP is represented by the lacrosse ball. You did it! You made ATP! Yay!